The physical reality of corporate AI infrastructure is massive. Rows of servers processing billions of parameters around the clock, consuming immense amounts of power and capital to sustain continuous operations. Building a system capable of actual autonomous work relies on several interlocking layers. An enterprise-grade architecture requires multi-agent orchestration, semantic memory, multi-channel routing, and real-time intelligence feeds running in parallel. These systems traditionally incur six-figure build costs and five-figure monthly cloud bills. This high cost stems from how the technology is packaged across organizational silos rather than the price of the compute itself. This comparative ledger shows the exact financial delta. On the left, the standard enterprise bill tops out around $300,000, with up to $24,000 in ongoing monthly costs. On the right is an identical, fully functional multi-agent infrastructure. It is operated by a single developer. The build cost is zero. The monthly operating cost peaks at $250. Operating a sophisticated AI company currently relies on a builder's ability to navigate consumer pricing models rather than their access to venture capital. The immediate objection from any technical builder is basic math. Running 6 AI agents continuously, 24 hours a day, requires constant communication. That volume of data should trigger crippling per-token API costs. This chart maps standard API pricing. When an automated system executes thousands of programmatic calls, the cost curve accelerates exponentially. But routing through consumer tokens like ChatGPT Teams and Claude Max hits a hard ceiling, assuming human users typing 50 manual queries a day. When you inject autonomous agents into a pipeline designed for human typing speeds, you exploit a pricing model that is 18 months out of date. An AI agent making thousands of complex strategic and coding calls per day pays the exact same flat rate as a single office worker. Decoupling the logic of large language models from per-token billing keeps the marginal cost of each additional agent call at zero. Layer 1 of the architecture is a specialized 6-agent executive team. 4 agents, CEO, CTO, CMO, Ops, run on GPT-5.4 and a $30 ChatGPT Teams token. Research and engineering handle continuous processing on Claude Sonnet via a $100 Claude Max subscription. These 6 nodes possess raw, localized intelligence, but isolated models operating in a vacuum accomplish nothing. They have no concept of time, priority, or systemic management. Raw intelligence requires strict workflow constraints. To prevent the agents from idling or drifting, the stack needs a dedicated operating system. Layer 2 is powered by Paperclip, an open-source AI orchestration tool. It operates on a rigid heartbeat schedule, forcing models to check in. The CEO receives a heartbeat every 4 hours, while the research agent pulses every 30 minutes. To communicate externally, the stack uses Layer 3, the multi-channel gateway, Openclaw. It handles external routing from WhatsApp, Discord, and Telegram, maintaining a direct bridge into the local development environment. Both Paperclip and Openclaw are open source. They run locally on the builder's machine. The cost to operate both layers is exactly zero. Combining a rigorous heartbeat schedule with an open-source MCP router transforms isolated language models into an integrated, locally managed computational engine. An executive team cannot function if it is amnesiac, nor can it operate without environmental awareness. It needs memory and a steady flow of external data. Layer 5 is a live intelligence pipeline pulling parallel data from 4 tech news sources, refreshing every 5 minutes. It fetches 50 stories, deduplicates titles, applies keyword weighting to score signal relevance, and sorts the output. Any high-relevant story under 3 hours old receives a chronological hot batch. This serves as a primary trigger for the research agent. To retain this intelligence, the system writes to Layer 4, the data layer, relying heavily on PostgreSQL 16, running locally inside a Linux subsystem. The database uses the PG vector extension. This translates all stored documents, news stories, and past conversations into vector embeddings, enabling deep, instantaneous semantic search. Redis operates alongside PostgreSQL, executing fast caching for the newsfeed and queuing asynchronous events to prevent agent processing bottlenecks. The system grounds every agent interaction in mathematical context. By forcing the models to reference specific historical data stored in vector form, the architecture significantly reduces the probability of hallucinations. The final layer is the public output, a live, production-grade web application built on Next.js 14, deployed seamlessly on Vercel's free tier. Whenever the engineering agent commits new code to GitHub, the front-end automatically updates and deploys. But the system's true interface is audio. The stack relies on an event-driven voice output system, utilizing a professional profile fine-tuned through 11 Labs. The design philosophy here is strictly proactive. It is not a reactive chatbot that you command. The system only speaks when a specialized agent surfaces a critical alert or a decision point. If the research agent detects a market anomaly in Layer 5, it triggers the voice pipeline. The audio generates via a Python script in the local Linux subsystem and routes directly to the physical Windows audio output, playing through external speakers in under 2 seconds. The dynamic between user and machine completely inverts. You no longer query the software briefs you. These 6 layers, agents, orchestration, gateway, data, intelligence, and web interface, interlock to form a complete enterprise-grade architecture. But the true value emerges when they execute an autonomous feedback cycle. It begins when the research agent detects an opportunity in the intelligence feed and logs a specific issue into Paperclip. The CEO agent wakes on its next heartbeat, triages the new issue, designs a development sprint, and delegates the exact technical requirements to the engineering agent. The engineering agent executes the code, runs the review, and pushes the feature live to the Vercel web application. The product iteratively improves itself. It detects a market signal, plans a feature, and ships the code entirely without human intervention, and without incurring any scaling cloud costs. An infrastructure processing thousands of complex operations daily, maintaining vector memory, and shipping live code remains fixed at a monthly cost of roughly $250. This is the compounding structural advantage of fully autonomous multi-agent systems. They run relentlessly in the background while the founder sleeps. The temporal window to build this specific stack using these consumer loopholes is entirely open right now. But as enterprise providers audit their API traffic, these pricing models will inevitably be adjusted and closed. In this specific window, architectural awareness has replaced capital as the primary lever for building dominant AI infrastructure.